All right. Hi, you guys. This is the chance to do, if you're interested to do this for extra credit, I'm just doing a quick screen recording, move this up out of the way. One of the things I'm going to start with, we're actually going to fill in this whole piece. So if you haven't had a chance to fill in this price demand data, you can. And I want to see how that works out for you. So it says find a model to fit the data on this apartment complex. Price, sauna, exercise room. The way you get this kind of data is basically what are you willing to pay for this particular apartment. Same kind of stuff that we did in class. We did the Chipotle data, which I'll show you, by the way, you can take a look at. Sorry we didn't get to share in class, but time does get away. So here is our original Excel. If I go to it, here's the price data, and I sent you guys part of this, but I've added to it some columns here to help explain kind of how this stuff comes about. The first thing is it says come up with a model for this particular data. Now if you grab my Excel spreadsheet, you can actually click on that particular model and then do copy. You can go over to this Word document and you can paste it right in there if you want. So it'll write that ever so nicely into that document. And I think the paste option that I just did put it in a funny place. Not to worry, we'll get it here in no time. But the idea is that you just need, here we go, there's the whole product here, and you can either grab just the piece of that model or you can grab the whole thing. And I think even from here I can grab that and just drag it out if you want to do a part of it. So any way you can get that copied into this particular document, that's great. And actually this nice look at this graph is actually really helpful. So generate a model, here's a graph of it, here's the function of it, explain your choice. And the choice that we do, as I mentioned in class, is I chose this model because it was a balance of simplicity with goodness of fit. That sounds kind of silly, but that's actually the balance of you don't want to overdo it and make it too complicated, but that's enough to get this thing right. Okay, so next, on the basis of the model you believe fits the best, which I've decided this fits the best, it says give the equation for revenue. Well, revenue is so nice because all you do is take x times the function that we had up above. And so I've already gone up into Wolfram Alpha, and I've actually got a copy of each of these models in here too. Let me go to my revenue function. So yeah, we can do this. Here's my, if I copy this piece here, this is my model that we have. I'm going to copy that one, go back to Word here, and show you in this document. What I have is this is the model. What I can do to come up with revenue, I'm just going to give you something. You guys can type it up and make it look nicer. Please do. But I'm just giving you an example. Is you just take x times whatever your model is. Now this one's not written out so nice. It's kind of written out in weird Wolframese. But you can take the model up above. Like I said, you can copy this little piece of the function here. I can copy this, highlight all that, and I can actually copy and paste it down below if that's your choice. But the idea is to get revenue, you just take x times that model in whatever form, and that's it. Give the equation for that revenue function. Now find the maximum revenue at corresponding price for that projected demand. So to maximize revenue, what we want to do is actually graph revenue, or we can do this, what's even better. I'm going to find the first derivative of revenue. So derivative and set it equal to 0 to 0. Now what I know is this is going to locate maxes and mins. With the help of the graph, I can actually put in just the maximum. Any maxes or mins, any relative maximums or minimums. And I'll choose the maximum just looking at the graph. So I'm explaining the process. I want to make sure we're clear about how you went about it. Okay, there's other ways to do it, but looking at the graph is a wonderful way to do it. So if I go back to our equation, I'll pull up Firefox in a minute, but I have the derivative of my revenue function. I actually wrote it in here. Here's the revenue function. So if I multiply through by x into what I wrote up here, if I distribute the x into that function, I'll actually write it down below. It looks like this. See if I can get a good copy of it. I'll just copy a piece of it. It looks like this function you see right up here that I'm highlighting. So I'll copy that and paste it down below. That one. Okay, so I distribute in that x to the third, and everything gets distributed around. And actually, I think I just put that in the wrong one. So the model up here is x. Hey, wait a second. This is revenue. There's no x times that. It already has it in there. This is revenue. You get revenue from taking that whatever price function that we had times number of units. And sorry if you noticed that before. So it's price times the number of units. And the result is this function right here. And I guess these are both the same thing. Okay, so here's price up here. If you multiply each of these by x, you have this function down below. Now to maximize, I told you I was going to set that first derivative equal to 0 for that function, and I've done that. So if I go to my graph over here, Wolfram Alpha, solve dy dx, I took the derivative of this, and that's d dx, by the way, is notation for derivative. We've used it in class, and it's also Wolfram understands it. And I set it equal to 0 off to the side here. Very cool command. If I hit enter, let it calculate and do its thing, which you already saw down below, you get this lovely little piece. It shows you two values, 19.86, and it also has 58.03. Now if I look back at my graph of that revenue that I just put in there, here's revenue, it looks like the maximum, this is revenue, the whole graph, happens at 20-ish, and the minimum happens at 58. So I'm wanting the maximum, so I'm going to go for that 20-ish number. So if I go over here, the 19.86, that's the number I want, and that's actually where my relative maximum occurs. So it occurs, so the relative max occurs at x equals 19.8. Let's get a couple of those digits in there. 862. 19.862. Done. Now what that means is I have a maximum 19 units, right? 19.862, and this is apartments. Are we talking about x as a number of apartments, or is it the demand in that particular, number of apartments that people are taking on at that particular price? So that's a nice way to look at it. So maximum profit occurs at 19.8 units sold or demanded. Okay, nice. Anything else beyond that? We seem to be losing some kind of revenue. And it says also get the corresponding price. The corresponding price, we actually have to go put that x into our price function, not the revenue function. If I want the price, I have to put x into the price function. Would be, and this is the price that maximizes, the price that maximizes revenue. Okay, that occurs like this. I'm going to give you a little idea. I'm going to take that function that I started with, this cool one right here, that price function, so I get that highlighted a little bit better. Yeah, it's thinking awfully hard. I'll get it from another location that I have here. So let's go back to y equals, there's my price function. So I'll go back to the graph. Sorry, computer's a little slower with all this recording stuff. But here it is, y equals this. That's our graphing price function. Awesome. And I'll copy that, put it back into my graph down here. And what I can do is, for that price, what I'm going to do at x equals 19.862 is, and then I'll find out the value of it. And in fact, I think I've done that here. I'm going to go check out my Wolfram. I believe I've evaluated this. Yep, here it is. Evaluate that original function at 19.862. Hit enter. Evaluates the way Wolfram does this. I'm just showing you one tool that works really nicely. You get 132.771. And so that would mean, that's in dollars, 132.771. So we'll just call it 77 for an apartment. That's a price that would maximize profit for this particular person, given demand. So you price it too high, you price it too low, demand drops and your revenues drop, or so corresponding. So this is all part and parcel. That price is what's going to maximize your revenues. And that's really actually what we're shooting for. You're maximizing revenue, you get the X that goes with that. But ultimately, aren't we in it for the price? Like, what am I going to sell this for? So that's what I have listed right here. All right, moving on. If I go down to the next piece, is this life expectancy chunk. That one got a little bit more complicated. And so I'll do that in the next video. We'll just call this part 1. And I will explain life expectancy in part 2. And then part 3 we'll be doing the data on Chipotle.